Let's now construct a binary tree using preorder and postorder. So note here is that in order is not given. So let's see if we can construct a binary tree, and if we can construct, then will it be unique? So let's see this. So preorder means root, left and right. Postorder means left, right and root. If both of these are given, then always you can like, even if one of them is given, then always you can make sure that what is the root. So here both of them are saying that one is root, right? Both of them are saying that one is root, so you will say that one is root. That is very much fine. Now this preorder is saying 1 2 3, right? It is saying 1 2 3, so it is saying this is root. And then now whether either like this 2 is on the left, or maybe 2 3 is on the left, right? Or maybe left is null and on the right there is 2 3, something like that, right? So like there are different possibilities. Let me just write root, left, right. And poster is saying 3 to 1, so 1 is root, that is okay, 1 is root. And then there will be left and right. Okay, so if you take 2 as left, then it is not agreeing with the post order for sure. If you take 2 as left, 3 as right, then pre-order will say okay, but post order will say not okay, which means there is a conflict between pre-order and post order. So will there be no tree, or what is the case? So what you can do, just think about it, like what we are doing wrong. So what you can do, you can take all of this as either left or right. If you're taking it as left, then according to pre-order it will be root and then left, and then on the right there is nothing. And according to post order it will be, see, you are taking this whole thing on the left, right? So it will be on the left, right? This whole thing will be left, and then you will be saying that there will be a root, that will be 1, and on the right there is nothing, right? So you can take this 2 3 as a left, okay? Or there is one possibility where 1 is on the root only, and you can say that this 2 3 is on the right. Why? Because according to pre-order, if you are taking this on the right, then according to pre-order it will say root is 1, that is for sure, that is not a problem. Then you will say that just a second, let me erase this. Yeah, so this is 2, this is 1, so this is root. Okay, so if you are taking this as a right, then you will say that on the left there is nothing according to pre-order. You can take this in the right, and according to poster also on the left there is nothing, right? See, they will not ask you to draw these kind of trees in the gate exam, but it is just for your exercise, like I mean your brain exercise. So it will just develop your intuition about these trees. Okay, I hope that is fine. There are two cases, right? On the high level there are two cases. Now let's just apply the same thing recursively, which means let's just focus on this one tree and let's see what are the possibilities. Which means one is root, which is fixed, that is not a problem. Now let me do one thing. Let me say that okay, let me determine between 2 and 3. That according to pre-order it is 2 3, right? According to pre-order. According to post-order it is 3 2. Okay, so it will say that, see, according to pre-order it should be root, left, right. So it will say that root is 2, which is fixed because root cannot be null. So root is fixed to be 2. Root is fixed to be 2 among this 2 3. Okay, let me do one thing. Let me draw separately. So here there might be multiple possibilities. So one possibility is that root is fixed to be 2, that is for sure. Now in this possibility also root is fixed to be 2. Now what about 3? Now this is root. Okay, now you can take this 3 as a left or as a right. See, 2 is root, which is fixed. Now you can take this 3 as a left. So if you are taking as a left, then right will be null, and here you can say this is left, right will be null. So you can take this 3 as a left, or you can take this 3 as a right also, right? You can take left as null, and you can take 3 as a right. If you doubt me, what you can do, you can just find out a pre-order of this, poster of this should match this, pre-order this should be this, poster of this should be this. Okay, similarly here also there will be two possibilities where you will be saying one is fixed to be root and another like 2 is also fixed to be root here, right? Then again you can take this 3 as a left and also 3 as a right. So there are 4 possibilities in total. That is how you can find out the 4 trees. Okay, now let's just construct a full binary tree. See what is happening now. We have given a binary tree. We are asked to given a binary tree. We are asked to construct a binary tree using pre-order and post-order. Now they are saying don't just construct a binary tree, construct a full binary tree using pre-order and post-order. In this case, I will show you. In this case, the answer will be unique. It won't be 4 or 5 like that in the previous cases. Okay, answer will be unique. This is very interesting case. Okay, I will summarize all the things at the end, but for now let's just understand this example. So you remember about the full binary tree, right? Full binary tree is a tree where you have 0 or 2 child. So this is a full binary tree, yes, because there are 0 or 2 children, right? Now let's just construct the full binary tree using this. So what we can do, using this pre-order post order, we can determine the root, which is A, which is very much fixed. Now since it is full, there has to be left, there has to be right. That is for sure, right? Now tell me, on the left, see, pre-order is root, left and right. Okay, left and right. So on the left, tell me, can D will be there? I mean, D is at least, I mean, minimum D will be there. Okay, because like left cannot be null, so right cannot start from here, right? See, root is A, so right cannot directly start from D. At a minimum, D will be on the left. That is for sure. I mean, that's why I'm writing. I hope you are understanding. At minimum, D will be on the left, because root this left cannot be null, right? So that is why at minimum D will be on the left. Now tell me, can DH be on the left? Maybe. Can DHL on the left? Maybe. Can DHLZ on the left? Maybe. Can DHLZP on the left? Maybe. Can DHLZPC, this whole thing on the left? Then your answer is no. Why? Because if everything is on the left, then who is going to sit on the right? Right? So on the right, I need at least one. So basically D will be on the left for sure and C will be on the right for sure. That is also true. But let's not worry about it. But for now, let's say that D is on the left. Okay. Now, once you determine that, okay, D is on the left, go to the post order. In the post order, just see where is D. D is here. A is over, right? A is over. So I'm just removing it. D is here. Now, which is on the left? Which means this part is on the left. Post order is basically left, right and root. So if this is on the left, then you will say that this whole thing will have to be on the left, right? I mean, it cannot be it cannot be like something cannot be here from the right, because this is root, this is root. Then if it is on the left, then this whole thing has to be on the left, right? And then what about this P? Can P be also on the left? See, DHL has to be on the left. So this whole thing has to be on the left. And what about this P? Can P be on the left? Let's just hold it for 1 second. Okay, I will answer this. Just hold it for 1 second. What about C? Can you tell me where is the C? So you will say that C will at least be on the right. See, right cannot be null. So C will at least be on the right. So just identify C here. C is here, right? So after that, everything will be on the right. So this CZ will be on the right for sure. But we are left with to decide about the P, right? So you are saying that CZ is on the right, right? So if CZ is on the right and P is coming in between here in the pre-order, so P will also be on the right. Okay. So I hope you get it. But we will not do that much complicated. Okay. We will do it very simply. We will do it very simply. How? We will say that whatever is there in the post order, okay, we will identify that D is in the pre-order. So okay, let me probably go to the next page and then let me explain you very simple method. See, what we will be saying, that first identify what is at least there on the left side. Okay, so you identified that at least D will be there on the left side. Just do this thing. Okay, first step is to identify what is root. Root is A. So once you identify that root is A, then do one thing, then just identify what is at least there on the right side, left side or right side, anything. So let's do with the left. Okay, so you will say that D is at least there on the left side, because left cannot be null. Now whatever, see, in this left side, okay, you say that root, left, right. Okay, in the pre-order. In the post order, you say left, right and root. So basically just see one order. Whatever is coming at the first in the pre-order actually comes at the last in the post order, right? So if root is coming at the first in the pre-order, D is coming at the first in the pre-order, then in this, for this left subtree, D should be coming at the last. So don't get confused. So don't go beyond this D from this post order. Okay, just say that, okay, first step is to identify the A and then identify, okay, D is at least here from the pre-order on the left side. Then go to the post order and just say that this whole thing will be on the left, this whole thing will be on the right. How? Because whatever is there in the first, in the pre-order, will be there in the last. So after that there won't be anything on the from the left side. Okay, so in the post order, after this D, there won't be anything. I mean, you can do some complicated here and there, like it won't be there like that. You can also do like that, but for simplicity, just remember this, or you do not need to remember, you can understand like this, that whatever is there in the pre-order at the first, the same thing is there at the last in the post order, and this is recursively, which means for the left subtree also, whatever is there, that is root, right? For the left subtree, just imagine only this left subtree part. So root is there, which is D, and you do not know like what else is there, right? So just go to the post order and say, okay, D is the full stop. After D you cannot have anything, because root is the full stop in the post order for the left subtree. So for the left subtree only DHL is there, right? And for the right subtree, since it is a root, A is the root, and then left and then right? So you will say that, okay, on the left HLD will be there, on the right PCZ will be there. So this one step is very crucial, where you will be determining the root and then left and then right. Okay, after that what you need to do? After that everything is easy. How? You can just apply the same thing recursively. Just apply the same thing for DHL. So go to this D, H and L. Okay, so this is L, right? So now for this DHL, pre-order is saying that D is root, and then H and L you need to determine, you need to basically identify between H and L. You can go to post order, but there is no need to go to post order here. Why? Because if D is root and you need to identify between H and L, then you can just identify from the pre-order, because these are just two nodes. So here either H will be here or L will be here, or vice versa. But from the pre-order only you can say it is root, which is D, and then left, which is L, H, and then right, which is L, right? That is how very easily you can identify. Or otherwise you can apply the same procedure. So you can say that, okay, pre-order is DHL. Okay, let me write here DHL. Post order is HLD. So you will say that, okay, D is root, that is for sure. Then on the left part, H is at least there. So just go here, and this is the full stop. So this H is the full stop. So you will say that this L will not be on the right part, right? Similarly, like you can identify for this PCZ. So among this PCZ, I think root is Z, right? Both are agreeing for the root to be Z. So you can say that root is Z. Okay, so you will say root is Z, and then you can say left is P and right is C. From the pre-order only you can identify. So that is how you can make a unique binary tree. So let me repeat it quickly. What you need to do: first identify root, then identify minimum node on the left, okay, which is D. Go to the post order, say that, okay, this whole thing is on the left, this whole thing is on the right, and do it recursively. So let's do one more example, and after that it will be more clear, I guess, right? So here you can easily say A is root, okay, and then just identify minimal thing on the left. So B is the minimal thing on the left, right? B is the minimal thing on the left, because it is root, left and right, root, left and right. So you will say B is the minimum thing. Now go to the post order, okay, and you will say that, okay, this is the full stop. So this whole thing is on the left, this whole thing, which is just E, on the right, and then A is the root, right? So you will say A is the root, B like whatever is there, and E, just E is on the right, okay, and B, C, D, like F, G, this is on the left, okay. Now do it recursively. How? Go to this. So A is actually cancelled out. I mean, like, there is no need to worry about the A. Now go to remaining nodes, which is B, C, D, F, G. So B is for sure, B is the root, okay. Among this B, C, D, F, G, B is the root, that is for sure. And then what you need to do, you need to just identify what is minimal thing on the left, which is C. Go to the post order and identify what is extra. So there is nothing extra, so only C will be there. And what is remaining? Your remaining nodes are D, F, G, right? So D, F, G, okay, these three, D, F, G. Let me just maybe just cancel out all of this, because these are not needed, okay. Only D, F, G are my interest now, D, F, G, okay. Now among this D, F, G, identify what is root. So obviously D will be root, right? D will be root, and then actually it is just three nodes, so you can just say FG, but otherwise you can just apply the recursively, which means you just identify what is minimal on the left, and then go to the post order and then say, okay, after this FG will be there, right? Just identify root, identify what is minimal on the left, or maybe if you are using the post order, you can use the minimal on the right, but let's go with one terminology only. So I will go with the post order. So just identify what is minimal on the left and go to the post order and just say that this is the full stop, and there won't be anything after this B or some other node that will be there in the there on the left. Okay. So this is the answer. I think we are matching with the answer A, B, E, C, D, F, G. Yes, right? This is the answer. Okay. Now let's do the final question, which is saying construct a complete binary tree using preorder. So here, see, now they are only giving the preorder, and they're asking us to construct a unique. Actually, unique is possible, so we can construct a unique binary tree, unique complete binary tree, just using preorder. And it is the simplest thing that we can do in this whole construction part. How? Just identify number of nodes, 1 2 3 4 5 6 7 8. So eight nodes are there. Let me just draw a binary tree, complete binary tree with 8 nodes. So you can at least draw the structure, right? So a structure will look like this: 1 2 3 4 5 6 7 8, right? So a structure will for sure look like this. Now just fill this structure with A B C D, A B C D E F G H. So you are getting why this structure is looking like this, because it is a complete. So complete binary tree with 8 nodes will look exactly like this in the structure form. Now what you need to do, you just take preorder of this. How to take preorder? Very easy. Preorder is root, left and right, right? So just go to the root, which is A. On the left side, 1 2 3 4. So 1 2 3 4. On the right side, this is 1 2 3, right? So on the left side there are 4 things. On the right side there are 3 nodes. So I'm just making like this. So this is left, this is right. Okay. Now go to the left. So it is root, which is B. On the left side, it is 2 nodes. On the so this will be on the left. On the right side, it is just E. So again on the left side D and then H, right? Okay. Now here it is basically root, which is C, and left is F and then G, right? So you can actually find out the preorder very easily. Now what you need to do? You just need to have a one-to-one mapping. You can say 1 is A and 9 is B, 5 is D, H is like, let me just write here, 1 9 5 4 2 6 8 7, which means wherever you have A, you just write 1, wherever you have B, you just write 9, wherever you have D, you just write 5, right? So why I'm raising, I don't know. So okay, let me fill these things. It will be just 1, right? It will be 1, and then wherever you have B, just write 9, wherever you have C, just write C is 6, right? C is 6, D is 5, E is 2, F is 8, and G is 7, H is 4, right? H is 4. So like it will be your tree if you construct a complete binary tree. If you do not believe me, what you need to do? You are convinced that it is complete, yes, and then you can just take a preorder. It will be this. So basically, it is actually very easy. What you need to do? You just make a structure, find out the preorder, and have one-to-one mapping, right? So that is how using one order, maybe preorder, postorder, in order, like whatever is given to you, just using one preorder, postorder in order, you can actually find out the complete binary tree, right? Here you need 2. Here in case of full, you need 2. I mean, if you have in order, then it is not necessary to have full also. Like if it is in order, then you can have go for unique binary tree in general. But if preorder and postorder is given, then you need 2 basically. You can't just generate a full binary tree uniquely using just preorder. You need preorder and postorder. So just to summarize everything, I will say that if it is general, okay, general binary tree, then you need in order is must, right? In order is must, and then you need either preorder, right? Or apart if in order is given, then you may also need postorder, right? If it is general binary tree, for the uniqueness, I'm writing for the uniqueness, right? If it is full binary tree, then you can have, I mean, if in order plus preorder postorder is given, then also you can do from them also you can do. Basically, it is general, so it is already covering full. But if preorder and postorder is also given, then also you can do preorder plus postorder, right? then also you can do uniquely. So these things are for unique. Let me write unique. Okay. And if it is complete, binary tree, then you just need one thing, which is one of the order, of the any order, right? So this is for uniqueness. I mean, for uniqueness, it is like some students just remember that, okay, from in order, from pre-order and post-order, it is not possible like that. It depends on which kind of tree we are dealing with. If we are dealing with full binary tree, then yes, it is possible. If we are dealing with complete binary tree, then just using one order, maybe pre-order, post-order, in order, whatever it is, right? Just using one order, it is possible. If we are dealing with general binary tree, then we need in order is must, right? This in order is must. Then we need either pre-order or post-order, right? If only, let's suppose, I'm not talking about the uniqueness, if only one order is given, and if it is general binary tree, right? For any general binary tree, then you have I think Catalan number formula, which is 1 upon n plus 1. You have these many, I mean, you do not need to actually remember this formula. You have these many binary trees, right, for general binary tree. So anyway, like this slide is important, no, not this one. I mean, this slide is not important, so let's not worry about it. This slide is important, where you, given the pre-order, post-order, you should be knowing that what kind of tree you are dealing with. If you are dealing with complete binary tree, then only one is enough. If you are dealing with full binary tree, then any two, basically, you can say any two are enough, okay. I mean, you do not need only pre-order and post-order. In order will obviously work. I mean, it is working for general binary tree, then why not for full binary tree, right? In order will definitely work, but you can have pre-order and post-order. So here I am saying any two are enough, any two. Okay, so let me just star mark it. Any two are enough. Here, in order plus either pre-order or post-order, right? I hope you are getting. Okay.